Imagine walking into one of the world's most respected libraries and asking to see the personal notebooks of a scientist who changed history. Instead of handing them to you immediately, a librarian presents a safety form. Before you can even open a page, you're warned that the notebooks are still radioactive. More than a century after they were written, they remain stored inside protective lead-lined containers because they continue to emit radiation. That isn't science fiction. It's a documented fact, and those notebooks belong to Marie Curie. Few scientists have left behind a legacy as extraordinary, or as dangerous. Marie Curie's research transformed our understanding of the invisible forces hidden inside matter. Her discoveries opened the door to modern nuclear physics and advanced medical treatments that continue to save lives today. Yet the same work that earned her worldwide recognition also exposed her to radiation long before its risks were fully understood. But before the Nobel Prizes, before the laboratory discoveries, and before the name Marie Curie became known around the world, there was a young girl named Maria Sklodowska growing up in Warsaw in the late 19th century. She was born in 1867, at a time when Poland did not exist as an independent nation. Much of the country was controlled by the Russian Empire, and strict government policies affected nearly every aspect of daily life, including education. For a child with an extraordinary curiosity, these restrictions could have ended every dream before it even began. Instead, they became the first obstacles in a journey that would eventually reshape science forever. Growing up under foreign rule, Maria faced challenges most future scientists never experienced. But the hardships waiting inside her own home would test her determination even more. In the next chapter, we'll see how family struggles and a forbidden education shaped one of history's greatest scientific minds. Maria Sklodowska grew up in a household where education was deeply valued, even during difficult times. Her father, the Ladislaw Sklodowski, was a teacher of mathematics and physics. Although political conditions under Russian rule limited his career, he continued encouraging his children to learn. Scientific instruments that once belonged to his school found a new home inside the family's apartment, and they became some of Maria's earliest introductions to science. From a young age, Maria showed an exceptional memory and an eagerness to understand how the world worked. She excelled in school, but academic success alone could not overcome the barriers placed before her. At that time, universities in Warsaw did not admit women. No matter how talented she was, higher education in her own country remained out of reach. Rather than accepting those limits, Maria joined an underground educational movement later known as the Floating University. Because Polish education was heavily restricted by Russian authorities, classes were held in secret and frequently moved from one location to another to avoid detection. Students gathered in private homes, quietly studying subjects that were often discouraged or prohibited under the occupation. Attending these lessons required both determination and courage. At the same time, Maria and her older sister Bronia made a remarkable agreement. Maria would postpone her own education and work as a governess, sending most of her earnings to support Bronia medical studies in Paris. In return, once Bronia became established, she would help Maria pursue the university education she had always wanted. It was a plan built on patience, sacrifice, and trust rather than certainty. For the next several years, Maria lived far from home, teaching children by day while spending her evenings studying mathematics, physics, and chemistry on her own. Every page she read brought her one step closer to a future that still seemed almost impossible. After years of waiting and sacrifice, Maria's opportunity finally arrived. But when she reached Paris, she would discover that getting into one of Europe's greatest universities was only the beginning of an even greater challenge. In 1891, after years of saving money and honoring her promise to her sister, Maria Sklodowska finally boarded a train to Paris. It was the opportunity she had worked toward for nearly a decade. Paris was one of Europe's leading centers of science, and the University of Paris, better known as the Sorbonne, welcomed women students, offering possibilities that simply did not exist in Warsaw. Around this time, Maria began using the French version of her name, Marie. It marked the beginning of a new chapter in her life, not a rejection of her Polish identity. The excitement of arriving in Paris was quickly replaced by the realities of student life. Marie rented a tiny room close to the university because it was all she could afford. The apartment had almost no comforts. During the winter, it became so cold that water could freeze overnight. Money was always in short supply, and there were days when she survived on little more than bread, tea, or butter. Historical accounts describe periods when poor nutrition caused her to collapse from exhaustion before friends persuaded her to take better care of her health. Despite these hardships, Marie refused to let poverty interrupt her education. She spent long hours attending lectures, studying in libraries, and reviewing notes late into the night. Many classrooms were filled almost entirely with men, but she remained focused on her work rather than the attention her presence attracted. Her determination produced remarkable results. In 1893, Marie graduated first in her class with a degree in physics. Just 1 year later, she earned a second degree in mathematics, again finishing among the top students. These achievements established her as one of Sorbonne's most outstanding scholars and opened the door to a research career that would soon change the scientific world. Outstanding academic success brought Marie new opportunities, but it also led her to an unexpected partnership with another scientist. Together, they would make discoveries that forever changed physics, chemistry, and medicine. By the mid-1890s, Marie Curie had established herself as one of the brightest young scientists in Paris. While looking for laboratory space to continue her research, she was introduced to a physicist named Pierre Curie. Pierre had already earned respect for his work in physics, and he quickly recognized Marie's remarkable talent. Their shared passion for scientific discovery brought them together, and in 1895 they married. Their marriage was unlike most of its time. Rather than pursuing wealth or social status, the couple devoted themselves to research. Marie even wore a practical dark blue dress to her wedding instead of a traditional white gown because it could later be used in the laboratory. It was a simple decision that reflected the practical way they chose to live. Not long afterward, Marie began investigating a puzzling phenomenon first observed by physicist Henri Becquerel. Certain minerals appeared to emit invisible rays without any external source of energy. Scientists knew the effect existed, but no one fully understood why. Marie decided to make this mysterious phenomenon the focus of her doctoral research. Working in a modest laboratory with limited equipment, Marie carefully measured the energy released by different minerals. Her experiments led to an extraordinary conclusion. The mysterious rays were not produced by chemical reactions. Instead, they originated from within the atoms themselves. This was a revolutionary idea that challenged existing scientific understanding. To describe this newly recognized property of matter, Marie introduced a new scientific term, radioactivity. The word soon became part of the scientific vocabulary around the world and marked the beginning of an entirely new field of research. The discovery answered one question, but it created an even greater mystery. Some minerals emitted far more radiation than scientists expected. Marie became convinced that these rocks contained something no one had ever identified before. Marie and Pierre were about to begin one of the most demanding scientific investigations in history. Their search through tons of ore would lead to the discovery of two new elements, and earn them worldwide recognition, but the cost of that breakthrough would be far greater than anyone imagined. Marie and Pierre Curie now faced a challenge unlike anything they had encountered before. Their measurements suggested that a mineral called pitchblende was far more radioactive than uranium alone could explain. The only logical conclusion was that the ore contained unknown elements that had never been identified. Proving that theory, however, would require years of exhausting work. The Curies processed enormous quantities of pitchblende by hand in a simple laboratory that lacked many of the resources available to larger research institutions. They crushed the ore, dissolved it with chemicals, heated massive containers, and carefully separated one substance after another. The work was physically demanding, and progress often came in tiny steps. From tons of raw material, they hoped to isolate only a fraction of a gram of the mysterious substances they believed were hidden inside. Their persistence paid off. In 1898, the couple announced the discovery of polonium, an element Marie named after her homeland, Poland, which at the time was still under foreign rule. The choice reflected her enduring connection to the country where she was born. Later that same year, they revealed the discovery of another element, radium, which produced radiation far stronger than anything scientists had previously measured. These discoveries transformed the scientific community's understanding of matter. Researchers around the world realized that atoms were far more complex than previously believed, opening new directions in physics and chemistry. Recognition soon followed. In 1903, Marie Curie, Pierre Curie, and Henri Becquerel were jointly awarded the Nobel Prize in Physics for their pioneering research on radiation phenomena. Marie became the first woman in history to receive a Nobel Prize, breaking a barrier that had stood since the awards were established. It seemed that years of sacrifice had finally been rewarded. But only a few years later, an unexpected tragedy would change Marie's life forever. Just as the Curies reached the height of international recognition, disaster struck without warning. In the next chapter, a sudden accident would leave Marie to face her greatest personal loss, and test whether she could continue the work that had defined both their lives. By 1906, Marie Curie had become one of the most respected scientists in Europe. Yet just as her career was reaching new heights, her personal life was shattered by an unexpected tragedy. On a rainy day in Paris, Pierre Curie was struck by a horse-drawn wagon while crossing a street. He died from his injuries at the age of 46. The accident shocked the scientific community and left Marie without her research partner, her husband, and one of her strongest supporters. Despite her grief, Marie made a decision that reflected the determination she had shown throughout her life. Rather than stepping away from science, she accepted Pierre's teaching position at the University of Paris. In doing so, she became the first woman to serve as a professor at the Sorbonne, one of Europe's most prestigious universities. When she delivered her first lecture, she continued the course from the exact point where Pierre's final lecture had ended, signaling that the scientific work they had begun together would continue. Marie also continued her research into radioactive elements. Years of careful experimentation eventually led to another remarkable achievement. In 1911, she was awarded the Nobel Prize in Chemistry for her work on the discovery of polonium and radium, as well as for successfully isolating pure radium. With this honor, Marie Curie became the first person ever to receive Nobel Prizes in two different scientific fields, physics and chemistry. It remains one of the most extraordinary accomplishments in scientific history. Even with worldwide recognition, obstacles remained. That same year, Marie was not elected to the French Academy of Sciences, highlighting that many institutions still struggle to accept women as equals in scientific leadership. Nevertheless, she continued her work, allowing her discoveries, not public opinion, to define her legacy. Marie Curie's greatest contributions were still ahead of her. As Europe entered the chaos of World War I, she found a way to use science not just to expand knowledge, but to save lives on the battlefield. Ironically, the invisible force she had spent decades studying would also begin taking a devastating toll on her own health. When the First World War began in 1914, Marie Curie recognized that her scientific knowledge could help far beyond the laboratory. She organized and promoted the use of mobile X-ray units that allowed doctors near the front lines to examine wounded soldiers without transporting them long distances. These vehicles, later nicknamed the Little Curies, brought medical imaging closer to the battlefield. Marie also helped train operators to use the equipment, making this technology available where it was urgently needed. Historians estimate that these mobile units assisted in the treatment of more than 1 million soldiers during the war. After the war, Marie continued directing scientific research and supporting the study of radioactivity. However, the dangers of prolonged radiation exposure were still not fully understood. For decades, she had handled radioactive materials with little protection, often carrying samples in her laboratory and working closely with them every day. The safety standards that exist today simply did not exist during her lifetime. In 1934, Marie Curie died at the age of 66 from aplastic anemia, a disease widely linked to her long-term exposure to radiation. Her groundbreaking work had expanded humanity's understanding of science, but it also came at a tremendous personal cost. More than 90 years after her death, Marie Curie's influence remains visible in physics, chemistry, medicine, and cancer treatment. Her original laboratory notebooks are still radioactive enough that researchers must follow special safety procedures before examining them, and they continue to be preserved in protective lead-lined containers. Marie Curie's story is not a mystery with unanswered questions. It is the documented history of perseverance, scientific curiosity, and remarkable achievement against extraordinary obstacles. From a young girl denied access to higher education to the first person ever awarded Nobel Prizes in 2 different sciences, her journey changed the course of history. If you enjoyed this documentary, don't forget to like the video, subscribe for more true stories from history, and let us know in the comments, which moment in Marie Curie's life impressed you the most? Until next time, thanks for watching.